All right, welcome back to the channel, everybody. Today we have a really interesting project. So this is our fridge. We got it back from Leiden Cryogenics. You've seen us trying to get it working before. We finally got it working. We got to 38 millikelvin, 0.038 degrees above absolute zero over the weekend. And now we're gonna take it apart and we're gonna start adding our experiment to it. So this experiment is top secret. We're not talking about what it is yet because we want it to be a surprise. If you'd like to guess, get in the comments and tell me what you think we're actually doing. All right, so first step, we're gonna take the shields off, get the fridge nice and naked, and we're gonna stick in all the experimental parts we built. First step is a leg workout. You gotta pump up this hydraulic jack high enough to lower the first vacuum can off. So that's what Caitlin and Josh are doing now. All right, so we're letting air into the outer vacuum can. There's also an inner vacuum can which currently has 10 millibars of helium on it. We'll keep that under vacuum just in case it's not all the way up to room temperature yet. If anyone wonders why this is so high, our goal is to be able to lower the vacuum can without breaking it in the middle at the to save time. In the end, did this to save time? Probably not. It probably created time by making this structure so enormous, but we built it that way, and so we're going to live with it.
I did. All right. Should be good to. So was this fridge actually designed to only be a probe fridge? Since it's so hard to, cycle.
We used it only as a probe fridge, but it was a fully functional dilution refrigerator with the probe option. When I say probes, they're actually these top loading probes. You can actually see them over here. These top loading probes allowed us to drop an experiment into a fridge while it was running. It was very useful in the early days of MKids when we were trying to get them when we had to cycle a lot of devices to get them working. But in the current, more mature stage, we don't use them anymore.
All right. Do you want to lower and I'll steady? Yeah. Yep. All right, so when that came down, it pulled forward a little bit, so we probably need to go back a little bit. I think we're still good. We're good. Ah, it was on the lip, like you were saying. Yeah. Yeah.
So this could easily have been 6 inches shorter.
Yeah. I may have put too much play in to not screw it up. And so you want to take the 77K off as well? Right there? All right. Let me know when.
I'm putting pressure on it, so.
All right, I'll go down slow. Hey, success?
All right, the inner vacuum can is still a little cold. We see a little condensation on it. So we're gonna stop here, and tomorrow we'll finish opening up and start installing all the parts. You can see the parts over here. So these are most of the parts. We have our RF wiring stages. We have some stages to hold it, some clamps. All this stuff plus a bunch of wiring is gonna go in tomorrow.
Hey guys, we're back with a more stable ladder.
I am kind of worried about the O-ring, right? So, yeah. Yeah, because this is a new one. So do you want to do the back ones first?
Maybe just a little. I guess we should probably try to go evenly.
Okay.
Since there's like 1 million.
All right, so everything seems to be out on this side.
Yeah, I just have a couple back here.
All right, I think we're good. Oh, cool, the O-ring release. That's shocking.
That's crazy that you managed to get it on
Yeah, it was annoying.
alone.
Okay, I'm gonna let it down, but you might have to guide it down so it doesn't bang everything.
Do you want me to be up here to guide it?
Yeah. I'm doing a help guide down.
Sorry.
Oh,
Do you want to hold it on for?
no, you're good.
Sorry.
The first thing we're going to install are the cables going from 300 Kelvin room temperature down to 4 Kelvin. So we're going to label and install these first. All right, before we can install the wiring, we need to check to make sure that the cables are actually good. So we have a vector network analyzer here, just turned it on. We're now going to set it up and calibrate it so we can check and make sure the cables work. So first we're going to measure, we'll say 10,000 points. And our frequency range, we're going to start at 10 megahertz, stop at 20 gigahertz. So full sweep that the network analyzer can do. So the first thing we'll do is we'll go to the calibration. We'll go to other cals, and we're going to do basic calibration. So we're going to be using the, our cal kit here is the 85052D. There we go. Connector is 3.5 millimeter. We're going to do a standard calibration, port 1 and port 2. We've got these connectors on here, so these are actually female, so we're actually going to do female with female. Okay, so we're going to hit next. So we're going to first do this is a short, so we can do the short first. This is the short, so we'll put that on to port 1. And we'll hit short. So it measured it. Now we'll put that on the port 2. Okay, now we have the open. Put that on to port 1. You're supposed to use the torque wrench, but my hands are a carefully calibrated torque wrench after many years. Okay, so this is the broadband load. So we'll put the load on. Load is done. On the first one, now port 2, we'll do the load. Now we have the through. Had a little trouble with this particular one. Hopefully it works this time. All right, now we're calibrated so we can measure. So this is our first cable. We're going to measure it. So we're measuring, we can look at the, let's see, marker. We'll go to like 4 gigahertz. So we've got like 8 dB. It's with some slope down, which is expected because this is a lossy Cooper-nickel coax. And a little loss is okay. And then, but S21 is down, 30 dB. S11, that means the reflection off one end. S22, the reflection off the other end also looks fine, below 20 dB, even at high frequencies. And S21 looks decent. So we've got minus 8 dB, 8.5 dB at 4 gigahertz, and then marker 2, we'll put that at 8 gigahertz. We're at minus 12 dB. So for these kind of tiny Cooper-nickel coaxes, I think that's fairly normal. So let's go, we'll compare this to another one and see how it works. So we'll install all these in the fridge and then do a final test once it's in the fridge and in its final install condition.
I love
Tight
these
space.
forceps for uncapping the tuning forks.
I'm removing these blanks on each of the fridge stages because we wanted to test a cool down and to make sure everything is isolated from radiation from each stage, we put in these blanks. But now that we're installing the wiring, we don't need the blanks anymore, so we have to take them out. Okay, it should be all the way down. Can you see them coming through at all?
All right, we've got all of the wires installed. Josh is now using the network analyzer to verify that all the cables are working. Once they're working, we'll proceed with adding the rest of the install. Okay, next we're going to install some of the hardware for the new platform. So first we've got these long posts. These should screw into the, right in here.
Success.
All right. Okay, well, now let's try to put on the bottom plate. We'll want to really crank down on that eventually.
Okay.
But this rod brings the 700 millikelvin still down here, and we'll have the stages sit right there. So the stages sit on this piece here. Essentially, this is going to go like this, and we'll hold it.
And then the stages.
And the stages will attach to that thing.
Yeah. And then there's an extension, hopefully, and then we'll be able to move.
Yeah, the extension's going to go down.
Yeah.
We can get the magnetic shield and stuff. Okay, so we've got to assemble our holder for the RF switches. So these are I think they're M2. Let's see. Can't do it with gloves on, they're too small. So we'll do it without gloves and then wipe it down with IPA before we install it. All these parts are made out of high purity oxygen-free copper with a gold plate with no magnetic underlayer, which usually people use a nickel flash. We're using nothing, just pure gold on copper, which is okay as long as you don't heat too much. We do that for thermal conductivity. At the temperatures where we're operating at, heat doesn't like to move around, so we need to give it some help. All right, so these guys, this goes like this, I think. All right, so here are the RF switches. These are 6-place switches, which means they have one RF input line, and then they can send the signal to any of these 6 outputs. So these are designed to go into this holder here. So hopefully this will drop in here. And yep, there's our holes. And so we can probably use, well, these are designed to use flatheads, so we might have to get those too. All right, so we gotta screw that on, put all these in, and then we can stick that into the fridge. All right, we got all 4 of the microwave switches installed. Now we'll get this installed in the fridge. Then we'll just put in the magnetic shield, and we'll put in the device platform. All right, next is this guy. There you go.
And the cables will come out and go in.
Well, we're currently missing the M8's flathead screw that's supposed to screw this into this rod extended from the still or 700 millikelvin stage, but this will eventually serve as a mounting plate for a stack of XYZ piezo stages, which will serve to hold a scanning module, which will pass over our MKIDs. We are attaching it to the 700 millikelvin stage because these are very long range scanning stages, much longer range than most available, so they'll dissipate a lot of heat. So we're hoping to heat sink it to a more powerful, a stronger cooling power.
Okay, so we'll put on a 20 dB attenuator onto channel 1 here. And then we'll have the hemped output on channel 2, so I'll put in just this barrel connector. All right, now we have another on channel 3. We're going to have another 20 dB attenuator. So we're basically putting in 2 MKID channels here. Channel 1 will be number 1 for input, number 2 for output, and then we'll have the second readout line will be channel 3 for input, channel 4 output. Okay. Okay. Tighten here. There we go, number 4. SMAs are old technology. We have in our newer fridges where things are denser, we have these flex cables and G3PO connectors that are much smaller and easier to, they're push on, but for robustness, it's hard to beat the SMAs. So I'm just putting them on and tightening them with this torque wrench, getting them all torqued to spec. At this point, my hand is a pretty well calibrated torque wrench, so. Okay, now we'll get the 2 amplifiers. So we have 2 different kinds of HEMTs. These are high electron mobility transistors. Each one has a noise temperature of about 4 Kelvin, which is really amazing. We also, these are wine reb HEMTs, we call them, because they come from Sandy Wine Reb. These guys are more robust. They have an input protection diode, so they're harder to blow up. And I'm got to put it in the right way with the output facing up. So they're nice for applications where you don't need ultimate performance. There's also HEMTs that we get from a company called Low Noise Factory in Sweden. They have lower noise temperature, something like 1.8 Kelvin in the 4 to 8 gigahertz range, but they do not have an input protection circuit, and they are more fragile. They break more often. So in this application, which we're not talking about yet because it's top secret, we don't really need that super high noise performance. 4 Kelvin is good enough. So we're going to use the more robust ones that we happen to have around the lab. This is not the world's best mounting solution from a thermal point of view, but it'll work well enough for this. And if it doesn't, we can always put a little more, put some heat sinking onto them. All right, so now we have these two. We have these 2 on. Now we can start adding the intermediate stages. So we can actually put this one on the top or bottom because of room constraints. I think I'm going to put this on the bottom. We'll probably put it like that, I think. All right, solid plan, but let's rethink. So these stages are going to heat sink the wires. This is the top plate is 4 Kelvin here. This is 700 millikelvin, the still. And so we want to limit the thermal conductivity between the 2, and we also want to block any radiation coming in. So these will act as little heat sinks and block black body. All right, now we want to get the final stage. All right, so these are niobium titanium coaxial cables. They go superconducting, so they have extremely low loss, which is really important, and they also have very low thermal conductivity. So that's a good combination for a fridge like this. The problem is these are, we're taking them from an old fridge, actually from the fridge of Nobel Prize winner John Martinez. And now now we got to figure out how to get them in and get them to the right length. So you can see we're a little longer than we need to be. What we'll do is we'll put a loop in there in order to get the length right. Okay, so we already got a partial bend here. And so we can just kind of keep going. Yeah, this is not the world's greatest bend, but we're bending a cable that's already been bent once, so.
A little bit of compression on it just so I can pin it straight.
All right, so I'm gonna mark this with a number 1 here, and I'm gonna put a 1 down here. So we know what we're doing. This guy's gonna be, well, let's wait till I've got it bent. So this one should be fine if we go there. And then, where would a good loop, I'm gonna put another loop here. This one's kind of all over the place.
This one has 3 minutes.
Okay, here we go. We got the, Now the final plate, we're gonna get these connectors on, and then we can tighten everything down. So this is number 3. That one goes over to here. This one is 4. It's gonna go right there. All right. So just got to put some bolts in there, tighten this up, and then we'll put in the intermediate heat sinks. There's little clamps. We'll have to bend them a little bit to make sure everything is in the right place. But then once we get everything set, we'll clamp everything together and put some tape on to block out any IR, and then we'll be ready to do the rest of the wiring. Just the room temp. We probably don't even need to do the room temp. The stuff at base temperature quite yet, but we're getting real close. Thanks for watching, everybody. We're really close to getting this totally buttoned up. We're going to do a little more wiring here. Then we've got a bunch of DC wiring for these RF switches, and then we'll put in the stages. So that'll probably be in the next video. All right, thanks everybody. See you next time.